So this is the application, MERN Docker. So what we are doing here, we have a front-end website where we attach to Nginx. And what we are basically doing is like the Node.js application we set up as a front-end. And we have a backend here where we are creating the user information and storing it in the database. Okay. And other than this, we have a MongoDB. We are taking a general one. And this is just Nginx. So these are the three things. And so every time what we are doing, we were trying to give our namespace command, namespace before every command, right? Let's say kubectl, you can get this one, okay? Kubectl get deployments. So we'll create namespace. Okay, kubectl get deployments -n datu. So yeah, I don't see any name. So what I will do is right now you can do this one. You can issue this command so that every time you don't need to apply any namespace command before the deployments. So let me give you this one shortcut. Okay, so this is the one. Just give it a try. Yeah, you can give it a try. Meanwhile, we'll explain what happened last week. So we tried to do a deployment last week. We tried to deploy a front end and back end website. So if I go to my guide, so this is what we did. We did a git the demo Docker demo clone. So we created a namespace, and then we were creating a like applying a front end manifest. Okay. So what we can do, we can apply front end or we can try applying back end. So let's try applying the front end file. Okay. kubectl apply -f front end YAML. So I'm not specifying any namespace. Ideally, since I'm doing a shortcut, right? Yeah. Can you try backend deployment meanwhile? If you are getting same issue, kubectl.
Yeah, backend is working.
Okay. So try to list your deployments. Yeah, Charan's backend is working. Mine is working. Yeah, Suprit's is working. Monica is still applying backend. Okay. Let me see if people are able to get that. I think even the front end started to work for some reason. Okay. So what I want you to do is I want you to increase your scale the both of this deployment to two replicas. Okay. So either you can do with your update your manifest file or you can do the dynamic scaling. Okay. So kubectl scale deployment front end. Yeah, let's go with the backend. Okay. Backend replicas is equal to 2. Yeah, let's just check that if you're able to get that replica count or not.
Yes, another pod got created.
Okay. So now let's go deep further about the pods, right? Like last week we seen the deployments. Okay. Now let's see about the pods. So usually when I was trying out the K8 lab, right, like people used to give me the BusyBox pod. So Kubernetes K create pod thing. Let's see. So as I mentioned, pod is a runtime pods that run a single container. Okay. In my terminology, pod is something like a holder. So ideally, it's supposed to store only one single container with additional supporting containers also. Okay. A pod manifest looks like this. Okay. Something similar to our deployment manifest. Okay. Okay, so here what we are saying API version 1, the kind we are creating is the pod type pod, and here we can create for Nginx, that is okay. So we are saying the pod name is Nginx and the spec containers. So here we do use to define like container specification. What is the name of the container and what is the image we are supposed to use. Okay. So usually we use busybox also. That is fine. Let's try with busybox. So yeah, so busybox, it just keeps the pod running in background. So we are not exposing any port here. So this is the configuration. So what I'm doing, like there is two types of ways you can create the Kubernetes components. So one is declarative and one is imperative commands. So declarative is where you will define a proper manifest and you will do the application. Okay, then you will apply the command. Okay, imperative as in you will do create it in the runtime. Okay, so what we'll do, we will create this one inside your this one, so busybox dot ym. Okay, so cut this, keep it here. Okay, so we will create this one. Let me comment this. Added busybox pod. This is done. I'll do a git pull here. This is done. Yeah. Now, if I see, I have you can also run the git pull command. So you should get this one. Okay. Git pull. Okay. So kubectl apply -f busybox YAML. So it will create a single pod. Okay. Just check if you are able to do it. Okay. Yeah. So I seen like you people spinned up the busybox container pod. Okay. Yeah, and I think the last session I was able to explain. Like, so let's run it with the -o wide. So this wide command, it will tell you which node it's trying to run. Okay. So it's trying to run in the worker node. Okay. So let's see. Let me set up that. Similar username. Yeah, so I'm creating the backend one for your usernames. So meanwhile, what I'll do, I'll log into worker node from here. So as I mentioned, like we are not using Docker anymore here. We are using container runtime CRI. Okay, so sudo CRI CTL get PS. Sorry, CRI CTL PS. So the commands will be something similar to Docker. Okay. So here, if you see, yeah, we have our processes are running. Okay. Now, ps-aux. I'll take one. So one example, like somewhere pod I needed. Okay. Let's take one example as Suprit's one. Okay. Mm, yeah, let me kill everything. It's okay. So click CTL. Mm, stop. No, click CTL RM. So what I'll do, I'll kill your busybox containers from the backend. Okay. We have the list. Let me keep it here. Yeah, there should be a way to identify which one is for which one, which user, but it's okay. I'm trying to kill everyone's pods here. Okay. Now I would like to know what happens to the pods now. Like I'm trying to kill it from the backend. So the question would be, does these pods will try to recreate, or do they will be in the died state or something like that? So what do you think of it, Minal?
Yeah, they'll be recreated, right?
Yeah, but we didn't create as part of deployment, right?
Okay. So only deployment ones will be recreated, others
Yeah, let's
declarative
see that.
ones.
Yeah, ideally. So I'm doing a stop. Okay. I'm doing an RM. Okay. Now let's try to run our kubectl pod status. Yeah, I think it still takes time to reflect, I guess. Okay. So if you see here, right, what happened is I killed a container from the backend. Okay, from the node, worker node. So the pod is able to create the restart the container. So why it did do that? If you see here, there is a restart policy. Okay. Yeah. So there is a restart policy specified, which is kind of a default one. Okay. Let me check the parameter. So usually the restart policy will be always okay. We didn't specify it by default. It will come with your pod itself. Okay. So if you want to check that, kubectl get pod hyphen -o YAML. Okay. You can get this one busybox pod and grep for restart. Grep -i restart. Okay. So check what is the restart policy set for your pod. Yeah, restart count one. The restart policy should be always, right? So yeah, just others also do check. We can proceed further. Yeah, from you. Yeah, so Preet, are we good to go?
Yeah, yeah.
Yeah. Okay. Now, see, that is the pod. Okay. So pod is trying to hold a container. Okay. Yeah. So pod is trying to hold a container. But what happened? Let's say your container got killed from the backend. Okay. So what it's trying to do, it is trying to restart it from the scratch. Okay. Now, if you see the imperative approach, okay, like this is the way we created through the like declarative, as in like we created a YAML file and then we did the stuff, right? So there is a way we can create the pod in a runtime using Nginx. Okay, kubectl create pod. Okay, it should be here itself. This is the one. Let me create for Nginx. Kubectl run Nginx hyphen image is equal to Nginx. Restart is equal to never. And let me give Nginx latest. Okay, run. Yeah, you can give it a try with that command. Okay, let me paste it here. So get pods. Uh, what about the busybox image which I ran? Yeah, I ran with the declarative approach. So yeah, it's okay. Keep it running. So I wanted you to create a container runtime with this, like with the uh, command actually.
So what will be the port number on which these run?
That's a good question, man. We didn't do port. Okay, busybox. It's just a dummy container which will run a command, a sleep in backend. Okay,
Okay.
so Nginx would be some what is it? Nginx would be 80, but we didn't give any services here, right? We didn't give any services to do the port expose.
Yeah.
So yeah, we won't get any output. That's okay. We are not going to the complete web interface and all. We are still like working out on the ports end to end. What?
Yeah.
Okay. So now the question is, okay, see, you are creating the things runtime, right? See, the difference between a pod and deployment is, let's say I deleted this pod. Okay. I don't have any, let's say, I'm deleting this file also. Let me move it to temp. Okay. Now, get pods. See, now the problem is, let me delete these two pods. Okay. kubectl, delete the, it'll take some time. Yeah, you can give it a try with it. It's okay. So the pod deletion will take some time, but yeah, you keep an eye. It's okay. Okay. So let me run the pods command again. for all namespaces. So Charan's box is still running. Think Supreet's busy box is still running. It's still terminating state. Okay, wait. Okay, now what happens is there is no manager here. As in, like, okay, you created this pod with this particular version. Okay, let's say you want to upgrade the next version of pod. Okay, you cannot do that simply because a pod is a single entity, it's a single holder. Okay, there is no management or a trigger on top of it. Okay, whereas if you see a deployment, there is a trigger, right? A deployment will control a number of pods here. Okay, we seen here. Think somewhere I wrote down the deployments. It's okay. So yeah, if you see a deployment, okay, what it will do, it will keep a watch on the list of the pods. Okay. Yeah, in an ideal scenario, if you ask me, do you delete the pods? Ideally, no, we don't. But let's say assume if a pod got killed due to CPU constraints or any other thing, okay. So there is always a manual thing that you have to go and manually restart the pod, okay, or manually start the pod from scratch now, okay. Whereas if it is a part of deployment, okay, the deployment will take care of it always. Okay. So as in, like, yeah, there are ways like the pods get terminated due to the OOM issue, as in the memory issue and all. Okay. So what we are doing, we are asking deployment to manage all the pods. Okay. Now, if you go back to the earlier state, where in the previous thing, how we are mapping the deployment to the pods is through the labels. Okay. We have a label for each pod, and we are giving the deployment to manage this particular pods with these labels. Okay, because there would be many other pods. Yeah, it can be its constraint and all, but we can ask deployment to, like, hey, why don't you manage this pod and all. Okay, so what we do is, if you go and inspect the labels, okay, kubectl, get pods, show labels. Okay. So if you see, the labels has a parameter called app is equal to backend. Okay. There is a key value pair app and the value is backend. Okay. So even for the front end also, there is a app is equal to front end. Okay. So what will I do is, I'll create a one more pod. Okay. With the same image as in front end. Okay. And I'll try to join this one to the part of a deployment. Okay. So let me do it. So I'll do in a a way we try to do. Like usually, when I was preparing for KTS, like I took Moonshot course and all. So there is a lot of shortcuts we get. So let me try to use that. Kget pod front end. Okay. -o YAML front end dot pod. Pod dot YAML. Okay. So I'll remove the stuff here. So yeah, I don't need all this metadata. So let me see what exactly is happening here. Okay. No, there is no volumes. There is not much of any creative volumes here. Yeah, there is no volume mounts, standard volume mounts. Okay. There is only one thing, the container port, that is also a default one. So what we are taking only content pod name, namespace, and the image. Okay, image is equal to this. Okay, let me create it with the command itself. It's okay. Mm, so our command is kubectl run front end 123 Okay, hyphen hyphen. Forgot it. 1 second. Yeah, 123 image is equal to 1 and restart never. Okay, so image is equal to this one. Okay, so what will I do? I'll do a label here. Okay, so let me give the labels. Labels is equal to app is equal to Frontend. I'm not sure if it is exact syntax, but let me see. Yeah. So yeah, what I did, I managed to set the same label as this one. Okay. Like we will see if the deployment basically tried to, yeah, if the deployment tries to join this container as part of the, join this pod as part of the deployment. Okay. So let me see the deployment. Okay. kubectl get deployment. Hmm. One second. Yeah, looks like it's not joining. Okay, I think it's due to the owner reference. What? Wait a second. For three, and I'm trying to check the owner reference, what it's matching to. No, it doesn't have any. Okay, let me check for the front end pod. Okay, so the problem is it's a part of a replica set. Okay, that's why I'm not able to join. Okay, so I don't think it's directly possible to do this joining the pod. Okay, but let's check the replica set here. Okay, kubectl. So how the deployment manages the pods is through replica set. Okay. Uh, so the Kubernetes, the deployment directly sends commands to replica set. The replica set will try to maintain the same replicas, whatever we mentioned. Okay. So that's simple it is. Yeah, let's see. Replica set front. Yeah, so this is the replica set, and it also works based on the labels. Okay, so yeah, we cannot join the existing pod with that, but the deployment basically tries to recognize the pods based on the labels. Okay, but you can check this one. Describe the replica set. Just check what is your replica set name. kubectl get rs. Okay, and kubectl describe your replica set. Just check, inspect whatever is there inside. Yeah. If you see here, right? Okay, like let me remove this. So if you see here, the difference between pod and yeah, if you see here, the difference between pod and a deployment is a deployment has a similar configuration. Okay, you see, we're basically matching the exact configuration, metadata and spec and all. So what we are doing, we are creating a template on top of it. So that is what. So we are, let me remove this. So we are creating a template so that it will repeat for each pod. Okay. And then we are using a replica count. And then how we identify the pods is with the labels. Okay. So here we define the port as port 80. as you mentioned.
So
See,
this
ideally, you
80 is port number of the container where the app is running.
yeah, man. Like, so it doesn't make much difference, like whether you add it or not add it. Okay. But yeah, one second. But here at this point, it's not make much difference. But when you're creating a service, right? Yeah, it's better to describe here port as a container port 80. Okay. Now, if you going into the pod security static pods, we'll go this one later. Okay, let's try with the services. Okay. So now, if you see here in your application, okay. So how does the application communicate internally, right? Okay. Let's see. Just take a standard VM. Okay. Now you have a front end. Okay. And you have a backend. And then you have a DB. Right. So DB has the port number of 3306 or 27017. That's for your MongoDB. Okay. So let's see some number. Okay. Okay. The backend will communicate on, I think, Node.js, right? I think it's 9,000 or 3,000. Yeah, 5,000 it is. We specified 5,000 here. That is okay. Okay. Front end, it's up to us. Like we can, through Docker, I mean, through container, right? We can expose a different port however we want. Let's say port 8. Now, all these things, they will try to communicate on this port, like port 80 and all. Okay. So all this communication, it is happening internally. Okay. So like if it is front end is trying to reply to backend and backend is trying to reply to database, right? So all these things is happening internally. Okay. Now the problem would be how you, when you are trying to expose a port to the user. Okay. So the user needs to have only access to the front end, right? So this is the one. So here we will give the port forward to the user. Okay. So whenever a service or whenever a pod is trying to communicate internally, so that is called cluster IP, where it is internal to the whole cluster. So we have a, whenever it's trying to map it to the user, right? Like it's trying to expose to the user, this is the node port. Like in simple terms, internal communication and external communication. That's it. So if it is internal, it's cluster IP. If it is external, it's node port. We have a load balancer that is for attachment of a load balancer. Let's assume you have a traffic or Nginx or anything. So for that type, we have a load balancer. Yeah, these are the three types of services we have. If you go and see your files, right, inspect your manifest files. So the backend, it's trying to create a service. Okay. By default, didn't mention any type. Okay. So if it didn't mention any type, the type is called cluster IP. Okay. And if you see front end, it specified a type, node port. Okay. And backend is also doesn't have any type. Okay. How do I check this? So I go here, kubectl, get svc. I suggest let's do one thing. Let's apply the front. You applied the backend. Okay. You applied a front end. Let's apply the MongoDB also. Okay. Now kubectl, get svc or get services. Okay. So here itself it specifies. Okay. So whatever is the type cluster IP, as I mentioned, it's internal, right? And here there is no expose here. Like you see, the port is not exposed. Okay. Now let's say if I go and run the quickctl here in the second one. quickctl ps. So whatever is the service running internal, we are specifying as the cluster IP. If we don't specify anything, by default is the cluster IP. whatever is we are trying to expose to the user that we specified as a node port. Okay. Now, here there is one thing. Okay, one concept which you need to get. Why we are getting into services? Why we not use the pods at itself to communicate? Okay. Now the question would be, okay, kubectl get deployments or pods. Okay. So now, if you see the pods, right? So how many pods are there? One pod. There is two. There is only one pod. There is here the backend is of one two pods. Okay, let's scale the front end to three pods. Kubectl scale deployment front end replicas is equal to 3. Okay. Now the question is, so each pod will have a IP address. Okay. So pods hyphen a, or let's say hyphen o wide. If you see here, there is a pod IP. It changes for each pod. Okay. See, the front end has a different IP. The front end second pod has a different IP here. The front end third pod has a different IP here. Okay. So if I put it here, 31, 32. Okay. So if you see your node level IP addresses, okay. So if config, or let's say IPA DR. So E0, it's working at this one, 10.1.1.0. Okay. And, or I think it's here also. Okay. So this is your node level networking. Okay. So now here the pod has a what you call pod level networking. This whole thing itself in a different, for the front end there is a this thing. So we have, let's say, pod level network. Okay. Now if you see for backend, like if you see the backend container, let's see how it is. Okay. See, the backend has a similar thing, but it also running in the same level of networking, 10.1.8, 1.0. Okay. So let's remove this one. I don't think this is needed. These are all front-end pods. Okay. So this is having 1.8, right? And you can also inspect it if you want. I think I gave you the command. Like, let's see, kubectl get svc services hyphen o wide. Okay. Kubectl get pods hyphen o wide. The wide will tell you more details. Okay. Additional details and all. Okay. Kubectl get nodes hyphen o wide. Yeah, just check what is the IP address coming for you. Okay, whether it's coming in the same range or not. Let's see. 1.10, 1.8. This is for services. This is a pod level networking. Okay, so we have a service level networking. Okay, but before that, let me check the pods for yours. Okay, like what about if creates pods created by Supri, okay, or other person. Yeah, you see, everything is running in the same range. 10.244, 1.9. 4. Okay. Now, if you see clearly, right? See, the namespace is a construct, as in it's just a virtual concept. Okay. So you are thinking like you might think, okay, my pods in my namespace and all. Namespace is a virtual context. Okay. It's just a layer on top of it for the user confirmation. Okay. Uh, the only thing is here all the pods they are staying next to next in a like this particular networking namespace. Okay, so even the nodes having a this range and the services, let's check that. kubectl get services hyphen go. I think service didn't come, but yeah, service has a different level of IPs. Okay, I'll tell you where that one is. But 10.103 and what is it 10.107. Okay, and 10.99. Okay, now the question is, okay, one simple question. So like not question as in the statement. So here your front end pods are running in the port 80. Okay, here your front end pods running in the port 80. Okay, my backend pod is running in some port 50. Okay. So now the question is how we are making sure to access all these things. Who is keeping a track of these records, right? See, you delete one pod, okay, you will create a one more here. Okay. There is no guarantee that it will create with the same IP. Okay. And how can I access this? Let's see. Uh, pods override. Okay. The problem is I cannot access the pod from the master because I am in a separate namespace. The master is in the I am in the node. Okay.
I have one question. So what is the difference between services and the pods? So in my case, services are running in one IP and pods are running in different IPs.
Yeah, I'll tell you. So the initial question was like why we are going for services if we have pods, right? So if you see here, right, you have 4 pods. Okay. Now you have 4 pods with the different IP addresses. Okay. And the port number would be same. That is okay.
Okay.
I was going to explain the concept next. That is okay. So now, what happens is these IPs are not constant. Every time these IPs are changing. Okay. So even the pod names are not constant. Okay. So if you write it out, okay. So pod names are not constant. Okay. So temporary and permanent. Or let's say constant. Okay. So if you write it, so the pod names are not same because if you create a new pod, the pod will name will get changed. Okay. Pod IP is also not constant. Okay. So here only the image is the constant. And yeah, you cannot say like, hey, I'll try to get with the deployment. No. Deployment part is where it's kind of a done where it's trying to create, recreate, healing, self-healing, and all that stuff. Okay. So if you get into this context, okay. So you have a port number which is common. Okay. But using the port number, can we identify the pod? No. Now the problem is it's just not one pod, it's multiple pods. Okay. The IP addresses keep constantly changing. Let's say if I write a script or if I add a load balancer like saying, hey, I'll list out these IPs and I'll write a node. Okay. And I'll try to save it. And then if a new pod creates, okay, that will try to you need to re-edit. So like this in a production system, you have millions of pods. That's not a workable idea. Okay. So we have one more constant. If you see here, uh, yeah, how the deployment is identifying the pods here. We discussed earlier, right?
Yeah. Labeled.
Labels, right? So, yeah, 1 second. Login, join. Okay, so if you see our deployment is identifying the pods with the labels, right? This is the label, that's why it's able to identify. Okay. Similarly, if you inspect the services, right? So the services we are saying the selector as label, app is equal to backend.
Mhm.
Okay. So we are using the same logic here. Okay. Labels. So we are using the same logic here. So every time someone asks, hey, I want to access front-end pod, front-end app, as in, so front-end, the services, it will go to service. Okay. So service has a list of dictionary it will maintain. Okay, see, this is the service. This is service one, service two, service three, service four. It's my issue. I can attach to any pod. That's not a problem. It's not a problem to you. So I will list out all the whatever is there in under my observation with the labels, right? So I will try to attach the pods to that one. Okay. Here, I think there is no owner kind of thing. I think in this you can add a pod with the same label and service can able to manage the traffic, send the traffic to that one. So that is okay. So, and let me try to access the pod with the IP address. Okay, let's see if it does it pass or not. Okay. Okay, kubectl get pods hyphen o wide should keep an autocomplete man. Okay, so if I take this, the front end pod ka, we remember the port number is 80, right? So what we'll do, NC-ZV, okay, ZV, port number, port 80. Yeah. If you see here, I'm able to talk to this guy. I'm able to check whether the port is opened or not. Okay. Let me know if you're able to open the pod. Are you able to open the pod? Let me give the command. Yeah, you can run this command. You can get into a dummy pod and you can get inside a pod and let's the command. Okay. So one command I ran is nc-zv. It checks whether your pod port is opened or not. Okay. Whether you are able to talk to the pod or whether you are able to establish communication from busy box to this particular port and this particular IP or not. Okay. And how can I check my app? So curl -v. It's HTTP. Let's see if does it work. Curl is not found. Wget. Hmm. Yeah, Monica, is it possible? Can you turn on your mic? Like with the voice, can we talk?
Yeah,
So
so yeah.
yeah. So now you mentioned like, see, basically with the pod, we can run multiple containers. So they have a shared network and storage. Yeah, you are going too explicit here. That is for the sidecar pods. Okay, sidecar containers.
Okay.
As in
Hmm.
here, you have one backend app pod and you have a log pod, as in like to collect the logs.
Mm-hmm.
So yes, here the pod, under the pod, inside the pod, there is a different level of networking. This is inside a pod, as in inside the here. Yes, the both of the pods, they should be. I will check that one. Okay, I didn't check. So they can have a shared network and storage. Yes. So you can have a main pod and sidecar container. Okay.
Mm-hmm.
And you can never run a main pod two times, main container two times inside a pod. So always it's a sidecar container or init containers. Okay, we will talk about init containers later. Okay, this
Yeah,
is inside
so
a pod.
whether it's a single container or a multiple container, the service, whatever we are trying to use, we are basically exposing our application to the outside world, right? So that's where we are using the service, right?
That's one way. And one more is we discussed, right? Even for internal communication. So here
Mm-hmm.
also we have the same problem. So that's the reason we are going for cluster IP. This is also one server, right?
Okay.
So
Inside the
even
cluster.
yes,
Okay.
as an internal networking, in order to communicate between this and this, so we are going for cluster IP.
Okay.
Okay. Yeah. So whatever you mentioned, that is one of the application. So this is also second application. Okay. Now
Okay.
coming to this, yeah, I want you to go inside a. Okay, let me see if I can get a wget preview. Okay. Wait a second. Let me know if you're able to spin up and get inside a busybox container. Do let me know.
Yeah, I can.
Is it working for you, Suprit?
So in this NC-ZB, so which IP address did you pass? The front end pod?
Front end pod IP address. So you can get yours also here, right? So
Yeah.
let's see. Suprit. Okay. So if you see take any front end port, 1.32 is yours. Okay.
Okay. So 80
Yeah.
port is for outside communication.
That's we defined, right? In the service, it will run on port 80. Yeah.
Yeah, we defined the node port also, right? Some big number. So what is that for?
That is, yeah, as I told, right? If you node port external outside the cluster, if you want to use it, this one to the end
Okay, so now
users.
we are inside the busybox pod. So for internal, we are using 80.
Yes, that's correct. Exactly, man.
Yeah.
So we are spinning up a pod here. We are trying to check whether it is accessible via IP or not. Okay. So yeah, you can try with this IP, whatever I told. I'm trying to get an inside browser, man. Let me see. Let me check if I can get it. apt install curl. Yeah, try that wget command. Okay, so check if you get a HTML file or not. Okay, I'm getting one more container, dummy container. Okay, so wait a second. Yeah, curl. Let me see my this one. That's okay. So yeah, either from yours in the busy box, if you can get the index file, right? You can try to do cat. You should be able to get it. Okay, that should be fine. Yeah, let me know if you are able to get it. You can try any front end IP. You can check any of the people who is running here, right? Any of these people's debug. Yeah, Suprit, you got the HTML content, right?
Yes, yes. So
Yeah, if you
debug
are
is
able
also
to
another
run.
pod.
Yeah, sorry.
Yeah, so debug is also another pod, which we.
Yes, debug is also another pod. We just created to access it from the same namespace because none of my containers has that shell access to run it. Okay, usually like so. Ideally, you're not supposed to have a shell access. So that's why. So that's why I took external one to create a shell access to access this. Okay. So you can try with this one also. Any of the port number, like let's say backend is 450, right? So let's say the backend is 117, and you can just check NC. That should be fine. Okay. NC-ZV. Okay. Backend is port kitna 5000. Yeah, it is open.
Yeah.
Okay. Now, what I say is this is a security issue. Yeah. Okay. Yeah, if you are able to get that pod running open or not, like as a port open or not, that's a good enough. Okay, now what I say is, see, all the pods are there freely communicating here, left, right, center. Okay, so you can pick any pod. If you have access, it can talk to this. If this one has access, this can talk to. This has access means it already has access because they are running inside a same networking. Okay, and they are talking freely, no restrictions and all. Okay, so that's why we are able to do it. Okay. So what I say is, we need a way to restrict everything. Okay, this part. Okay, like So for that, we go for network policies.
Before jumping on that, I have one
Yes,
question.
sure.
So we created this debug pod, not via
Yes,
deployment. In a runtime, we created. How come
yes, that's
these communicate with the deployment pods?
yeah. As I told, see, a deployment, it's just a manager you can think of. As I told,
Okay. Mm,
deployment and replica, they are a managers. They are creating the pods, deleting the pods, and all. Okay.
mm,
Once it's created, this task is over. All the communication, everything will talk to the services, will talk to the pods, not the deployments.
okay.
As I told, they happens between because of the labels. Correct?
Mm, mm,
Yeah. Yeah. Now you see, this is a security issue, like where you are able to talk freely with anyone, anything, and all. So what will I say is like this is the okay. So let me create an what is it? Network policies. Yeah, let me update my GitHub directly. One second. Let me create for front end. Yeah, let me give complete configuration. Yeah, I'm just generating the manifest files. Give me a minute. So let me create a wait. I'll create one policy. Front end np.yaml. Yeah. So this one, so this is a type something called network policy. So you have something called okay. Let's say if someone comes to me, okay, or if I need to take interview for a person, or if someone claims that they know a technology or something, they know a tool. So the first question I'll ask is, what is the best practices? Okay. So best practices you follow in order to make sure things work smooth. So in the best practices, this is one of the best practice we do. The network policies make sure the access is not going anywhere. Like the to and fro communication is not happening like this. The way we are communicating, like from here to there, there to here, and all. The pods are communicating basically. There is no. Let's assume there is a malware inside. It can talk to any pod at any port and all. Like there are CVEs, critical vulnerabilities and all. Okay. So let me define the namespaces. See, this one, this is a default deny all policy. Like basically it will stop everything. Okay. All pods communication and for anything. And it's not selecting any pods. So so that all the pods communication will stop by default. Okay. And it will work only for this namespace. And there is a second one. This is a front end ingress. So here we are selecting the pod front end and we are selecting all the namespaces right now, but that is okay. And what we are saying to access the front end, right? Like we are specifying this policy, the ingress to communicate with this. Okay. Yeah, so this one is egress. So for the front end part, what we are saying, the communication to the front end, it should not talk to outside. It should be able to talk to something like, yeah, it should be able to talk to backend on the port only 5000. It should not be able to talk on any other port. Okay, so we are specifying one more. Yeah, this is a good one. This So here we are selecting the pods. On what pods this is applicable. We are selecting backend pods. So the policy type ingress as in incoming traffic. So it should accept the traffic only from the front end pod. It should not accept from any other pods. Okay. The DB pod cannot access directly. The any other pods cannot access directly. So only the front end pod can communicate with the backend. The incoming traffic should communicate with the backend. Okay. Now, this backend will communicate to DB. This is egress. Okay, let me give it. And we are applying one more on Mongo. Ingress only from the backend DB. Okay, and is it done? Let me check what is my thing networking. One second. Yeah, I'll save network policies. Let me see if that is work. But the problem is we took a provider for Fanel. I think that's the reason it might not work. But let me give it a try. I can try, but I think it might not work. Let's see. DWD cd docker demo git pull. Let me commit it. Okay, I'll try whatever I showed you earlier if it is still working. Let me see. kubectl debug pod. kubectl. Okay, delete for debug. Yeah, can you check? I think you still should be able to access. Can you check if you're able to access still? I applied the network policies, but according to documentation, it should still work. That is okay. I'll try once. Yeah, it's still working. So the problem is Yeah. So the problem is, if you see our kubectl cubes, k get pods, -n-a. Okay, if you see ours, right? So earlier session we discussed about the Kubernetes components, as in we didn't discuss in deep. So we discussed about this one, the funnel. This is a networking tool. Okay, so all this pod level communication, right? Like with this, who needs to get this IP, who needs to remove a new IP has been released and all. So there needs to be create an IP address, okay, delete an IP, okay. So the node level networking you don't need to manage. Service level networking, there is the Kubernetes service will take care. Kubernetes will take care of that. For the pod level, you need a external networking tool to do this, okay. So what happens is like you need to create an IP, you need to assign an IP to pod, okay. You need to delete an IP when the pod is deleted. So all these are tasks supposed to be done, and it needs to make sure all the things are happening smoothly, okay. So for that we are using a multiple networking tools. So one is something called funnel, and we have calico, okay. And let's see, it's CNI networking tools. Yeah, you can say network plugins. Yeah. So if you see, this is a container runtime, that is okay. So this third-party plugins, okay. So as in we have a Calico, we have Cilium, okay. I didn't work with the ECS CNI. I think this is coming a default one. Coming with the default, you have Meter. I think these are the default ones, man. Okay, there are some more names. I'll give you that. ViewNet. I worked with Weave. Okay. So I'll give the names so you might remember when you came across. Okay, Weave, Cube Router. I didn't work with this. Okay. So the problem is panel doesn't support this network policy. So whatever the network plugin we are using, we are using funnel here. So, but the panel is not supporting this network policy. That's why we are having an issue. So if I do it now, I might need to recreate the cluster again. Like that would mess up the things. But we'll take a pause here. Mm, I think even the Ingress, right? I think Ingress is a different topic altogether. But let me open the Ingress and let's see if I'm able to let's see if we can access the application directly. Okay. So kubectl up. Let's see what is there in Ingress. So Ingress memdemo.local to frontend port. So what will I do? I'll change this one to memdemo.shishilata.com. This one is using Traffic. So this is a load balancer, as we mentioned earlier. So load balancer, what it tries to do, it will try to it will try to establish the communication between outside world versus the inside one. Okay. So when a user is trying to attach a DNS, so when a user is trying to access the service, so the first one, it will hit DNS, and then the DNS will touch to the load balancer, as in reverse proxy, you can say. Okay. So here we are using, for this, we are using Traffic. We can use Nginx like you have a n multiple tools. Okay. We also have service mesh that also covers the services. Like how does the you can get the metrics between the services and you can get the traffic between the services and all. That also covers through this one itself, the reverse proxy. But that context we might need to, that's a kind of advanced concept. We will debug further. We'll get to know that one further. Okay. One small thing, let's try to set up this one. Okay. Front-end port IP, and it's in my namespace. Let me see if I can get it up. Okay. kubectl apply -f. Okay. Get ingress. Okay. Kubernetes get ingress. It will show you the ingress, which port it is right now. Like as in ingress is end user serving the front end user. So that's why the port number is 18. We can get the endpoints. Okay. What endpoints it's serving the IP. Okay. So as I mentioned, it's giving the pod the node IPs, I think it is. Okay. Get nodes. Yeah, basically it's serving on all the nodes like master and the worker node. Okay. So what will I do? I'll attach the MERN demo to this one. I think somewhere something got messed up. It's exposed everything. That's okay. So let me set up my DNS. Hmm.
So if Ingress is there, the service of frontend can be cluster IP also. It need not be node port, or it should still
No,
be
it
node port.
should be, yeah, I mentioned that, right? Like, uh, yeah, it can be node port, but usually we do default dedicatedly
Yeah.
mention cluster IP and load balancer for the best practices. In the production, we do specify cluster IP and the node port. Okay. So usually we will give it to node port or load balancer. Okay. Let me set up the DNS. One second. My URL is this MERN demo, and I'll try to give these two IP addresses. So does it take like this? Okay. Added the enter. Uh, Mine is MERN demo. One second. Yeah, messed it up. One second, guys. So this is the IP. I'll check. This is the URL. I'll check if it is reflecting or not. DNS checker. Okay, it's reflecting. Let me open this one. Okay. So man demo. Okay, this is not HTTPS. That is completely fine. We will talk about HTTPS in a different section. How to set up the TLS. It's taking so much time. Yeah, I think this is trying to get some time. Okay, let me try to open with port directly. Okay, kget SBC. So 32071. So 32175. Let me open the master. Think, yeah, from master it's working. Yeah, that is okay. Let me see. I think the DNS reflection is taking some time. That is okay. Just check if you can able to open your application in this particular port. So I think let me check yours, everyone's. Okay, get SVC. Yeah, you can check yours here. 30678, I think, and 32175. 44204 96 83 32175. Let me know if you're able to access the application. It might not work as expected, but that's okay. Yeah, I'll try to access one by one, man. 32. Yeah, let's take this one. 32161. Yeah. Supreet, I'm trying to access yours. 32161. That's okay. Yeah, I'm able to get yours, Supreet.
Yeah, even I could access.
There might be problem with your DB or backend. That's okay.
Yeah.
Charan, you want to try or let me know if you are able to access?
Yeah, I can access it.
Yeah, Monica, can you confirm? You can confirm in the chat if you're able to access.
I can.
Okay. I'll explain. So the DB problem, I'll explain the here. Okay. So I'll explain the next set. So the problem is the database, it comes with the storage. Okay. But it's not a proper storage we are doing. And we didn't initiate it proper way also. Okay. So that's the thing. It can work, it could not work. We are using a pod here. Okay, instead we are supposed to use something called stateful set in order to specify this one properly. Okay, so we'll discuss the storage in the next set properly. Okay, before that, I'll explain you what is DaemonSet. Okay, you might have already come across this, but let's see. So DaemonSet is where, let's say, I wrote a monitoring application. Okay, where or you can write a one monitoring application where it's collecting the node metrics. Okay, and where it's collecting the list of the containers running there and what is their health state. Okay, so this is in this one. Okay, you don't the deployment. The problem with the deployment is so deployment will not never mention you which node it will go. Okay, so we didn't go to the deployment strategies yet. Let's discuss about that. Okay. So coming back, so deployment you need to specify a way. Okay, there might be sometimes where okay, let's see, let's keep it here. Okay, so you have let's assume 5 nodes. And you have a deployment. Okay, this is a node 1, this is a N1, N2, N3, and N4. See, the problem is it can never guarantee where your pod will go. Okay, let's assume you spin up 4 pods. Okay, there is no guarantee that the 4 pods will go into 4 of these nodes and all. No. So if the node 1 capacity is good enough, all the 4 pods will run over here itself. Okay, so you cannot achieve anything. The way which I'm trying to get the metrics of the nodes. Okay, something like a monitoring application, you can say something like Prometheus or a Neuralink pod or any other things. Okay, so it also is itself is a pod, but the thing is there is a rule that it needs to run on every node. Okay, in order to get the information, but the regular deployment will not satisfy that criteria. So that's the reason we are going for DaemonSets. Okay, either you can write your own application or we can try to use any existing one. Okay, Let me try to get one. These guys, the Kubernetes guys will have excellent documentation, but let's try to take example from them itself. Yeah, this is a Fluentd Elasticsearch. Okay, so I'll add this in our thing. Yeah, wait. And you, let's say DaemonSet. FYI, Daemon, if you people are already aware, Daemon is the one which runs our services in our, uh, VMs inside the nodes. Okay. So I'm not sure of the reason they picked up, but they are trying to, maybe, I guess, maybe they are trying to make it as a service kind of thing, to look like a service kind of thing. So daemon is something where it's invisible and runs in the background. But here in this case, we are trying to make it run on every node, one node, one pod. So that criteria must be satisfied. So yeah, I'm just copy pasted the example. So I don't need to go in depth and what is it they are doing. So let's see. I'm committing this. Added. Yeah, I can do this. So, skip for now. DaemonSet. Thought I committed. It's okay. Pull and let me do a pull again. Yes. Okay, so I'll apply a daemon set. So I cannot spin up a new node right now, but it's okay. So the expectation is each pod should be running on each node. So k get pods. Yeah. Damn. The problem is, think. Yeah, let me see. It's running or not. K get daemon set. I did apply. Didn't work out. K get ds. Crap. One second. Is I'd say, okay, I think I made one mistake here. Okay. So when specifying daemon set, this guy has a, yeah, see, this guy has a namespace built in inside. So due to that, it was going to kube system namespace, which is a default one. So what will I do? I'll apply the daemon set with my namespace. The two. Okay, here the priority is getting from the YAML file. Okay, looks like so. Let me show you that.
Maybe we
So
can edit that in locally.
yeah, that's what it. So what will I do? I'll remove this namespace context directly. Okay, so yeah, so I remove the namespace. I'm editing it, updating, remove because I want you people also to try it. Okay, this time it should work. Okay, you can also give it a try. Let me see. kubectl apply -f, your namespace name. Yeah, do let me know once you tried. We'll get. Yeah, it went way ahead of the time. Depth for Fluentd. Yeah, man. So that's about the daemon set. So I guess we can conclude. Sorry for the delay because it took some time to set up the lab. I'm trying to automate it with Ansible. I'll give you that setup later point of time. I'll explain how did the automation part. The reason I'm taking AWS because it's providing more of latency for me. Like it's solving the latency issue for me. But let's see. Yeah, before moving further, I'm gonna ask the question. What topic could be the next one? So the question would be, yeah, is there any questions here so far? Whatever we discussed, right? Do you have any questions?
So this daemon set will be applied to all pods now.
No, it itself is a pod, man.
Okay.
Yeah, you see the kubectl get pods, kubectl get pods. Did you check for it? You see the command?
Yeah.
It itself is a pod. Only difference is it will run one per node, one pod per node.
Mhm.
Whereas deployment, it will make sure it is high available, but it will take care. It doesn't matter. Okay, it will have its own logic how to schedule the pod, which node to schedule and all. So yeah,
Okay. So it will monitor all the pods running in this. So
daemon
what is
set. You are asking,
yeah,
right?
yeah.
Yeah, it works the similar way. Let's see. kubectl -o wide. Okay, sorry, my bad. So I'm running it. So you see, one copy of pod is running in one different node, right? So one is master and one is worker. So let me delete one pod. Okay, kubectl delete pod, and let me delete both. It's okay. You see that?
Okay.
Yeah. Any other questions? Sukrit, do you have any questions here?
Yeah, so node port concept I understood. It's for exposing our application to outside users. So that I understood. But how does Ingress come into that picture? That ingress.yaml file I didn't get properly actually. So we mentioned that URL MERN data dot something, right?
Okay. So like we will take English in a separate chapter if that is okay.
Yeah.
So yeah, any other doubts? So Ingress, as I told, it's a service mesh. It does have a lot of stuff.
Yeah.
You need to know about TLS. Like all it's doing, like see, basically you can access your application at specified port and specified IPN port. Okay, but Ingress makes things easy for you. Okay, but we will discuss about it. Yeah. Any other questions you have?
No, that's it.
DaemonSets, pods, like pod scheduling, the containers using. So,
Yeah, I think I got a good idea now. Yeah.
okay. Yeah, I hope you're getting better, right? I
Yeah.
assume. Okay. So yeah, I'll get my VPS up, man. Some issues there. I'll try to get it up. It's okay. Now the next question is, how do you want to proceed? Do you want to proceed for storage, or do you want to proceed for scheduling?
Scheduling in the sense like load balancing kind of thing.
No, not exactly. See, let's assume, yeah, you have the node here, N1. Okay. It has one CPU. Let's call it small. This is big CPU. Let's say 4-core CPU. Let's call it big. Memory, big memory. Uh, let's call it very small node. Okay. Or let's say GPU node. Let's call it GPU node. Okay. Now, how do you define this is scheduling? See, it has a pods. Now, sometimes you'll say some of my deployments are something like, okay, if it is Nginx, it should go to run this one. I don't need big. Okay. Now, if it is some daemon data processing or something, okay, I want to go to GPU. Okay. If you are running a very big application, something like front end where users are exposed, okay, this one. Where I'm running some other different applications, okay, you want to run here. Okay. If none of the requirements are satisfied, you want to go this one as a default node for the pods. Okay. So, that's how you want, right? Like when you are scheduling a pod, okay, you have requirements, right? So where your pod should go in, okay. What kind of VM you are looking, like here you don't have choice for the selecting the node, correct?
Yeah.
Yeah. So in the scheduling, you can get the choices. Okay. So my pod supposed to go to this one. Okay. My pod supposed to go to a big VM. My pod supposed to go to a VM has this many, this has GPU. This pod doesn't have anything. It can go anywhere. Doesn't matter. Why we need all this thing? This is for the capacity plan,
Yeah.
maintenance, cluster management, whatever it is. Right?
Yeah.
And one more is you have the limits. Till now, you are not specified the limits. Okay, see. CPU limits, memory limits involved. Like in Docker also, you can specify the limits. Limits as in how much CPUs it can utilize. Let's say this has 4 CPUs. Okay, it can only utilize one. Okay. You can specify the CPU or it can exceed more. Like let's say if your pod is trying to consume more memory or something, you can ask it. Like it's like a vertical. You see, you have your pod. You know how you have an idea. Okay, each pod supposed to have this much memory. Okay, you may not be a developer. Let's assume you're an architect. You know, okay, each pod supposed to have this much memory, this much RAM. Then only it will work functionally properly. Okay, so I want to have, like, you can take Jenkins, right? So can I run Jenkins pod? Okay, in 500 MB or let's say 256 MB RAM. Can I run that?
Maybe not, right?
Yeah, it can run, but users will not have functionality. So you know I need to have 1 GB RAM, 1 gig RAM. Correct?
Yeah.
So like that, you have a definitive requirements. Okay. I'll try to give several examples. I'll try to get some several examples. Okay. So you have that many requirements. Okay. And you need a way to find like your pods to go here. Okay. And you have a cluster management. We'll go to that one, like as in no, how do you upgrade the nodes, right? There is a cordon. Let's do, you're setting up a cluster, new cluster, or you're trying to upgrade the nodes, right? So let's say assume you have the kubectl get nodes, right? You are in 1.28, you want to go to the next version. Okay. That's for the node upgrade management. Okay. That also might come here, but we will discuss why. Let's assume you want to take one node here out of maintenance. Okay, this node went into bad shape. Okay, you don't want any other, let's say, this went into bad shape. You don't want any other parts to schedule here. You cannot go and change the manifest files and all, right? Did you got the example I'm saying?
No, not this one.
Okay, see, in your manifest files, you gave the requirement, GPU, memory, and all. Okay.
Okay.
Now, let's say one of the pod here, one of the node here, okay, went into bad shape. The node is in an unhealthy state. Okay. Now you want to take this one out of for maintenance. A different node will come. Let's say you schedule auto scaling, a different node will come and set it up here. But that's okay. But you are taking like this one out of maintenance. Okay, you don't need to create a new node. So you want pods, whatever the new pods are coming, to schedule only in both of these, not this one, right?
Yeah.
So this one you will mark for maintenance. Okay. So yeah, we can get to know how to do that, but you got the context, right?
Yeah.
So this is all will come in the scheduling things, pod scheduling, and storage also a different concept. So if you tell me which one you would like to go, storage as in how do you manage the storage for these containers or the pods and all. So that is it. Yeah. You think and let me know which one you want to go for. So based on that, we can proceed.
Yeah. So will we have the next class like next week or that next week? I might not be there in the next week. That's
Yeah, I mean, it's okay, man. You don't need to stress because it's holiday time. That's fine.
Yeah.
Everyone will plan.
Yeah, that's what. For me, like anything is fine. Either one is fine. Maybe Charan can mention if you have any preference.
Anything is fine. I'll be
Maybe whichever you feel is correct to go now.
This one that you explained now. Balancing something.
Yeah, I'm checking the calendar, man. 1 second. I mean, everyone will be on holidays. It's okay. Even I do need a holiday.
Yeah.
Yeah, it's 28th, man. It's a year end. It's okay. Maybe we can sync up at 4th.
Yeah.
Yeah. Meanwhile, I'll get the lab access properly, set it up. So. Yeah. So see, the problem is lab setup is taking some time. Today some people joined, new people joined, and they are having some problem and dropped off. That's okay. Yeah, I'll get the things for you or Monica. Like I'll try to get up the things, keep up and running when you log in. The reason VPS I'm not taking because VPS has a problem like latency issue. You might feel slow in the lab, so that's okay.
Okay.
Yeah. So you need to come and decide. Let me know whether you want to go for a storage or you want to go for a pod scheduling.
Yeah, sure.
Yeah. As I told, there's a lot of concepts. We have security, we have networking in depth, we have security, we have DNS, we have RBAC. The security will come under the RBAC. You need to know how do you schedule the certificates in between. And yeah, I think what will I do is I'll not go into cluster in depth because you are learning the deployments, right? Applications, how to deploy the applications. Okay. So you will try to cover maybe pod scheduling and then storage. We'll see. And then Let me write it down. So pods, storage. Okay. Now I have this one, RBAC. Okay. How do you create a users and service accounts, right? Or we can say users and service accounts both. It's okay. And service accounts. And what else is there? I have the networking that will come under cluster maintenance. Okay. And new cluster creation and upgrading the cluster. Okay. And cluster policies. You have cluster policies. Yeah, I think you have this one, right? I forgot the name. YAML file they will regenerate Helm. Okay, and then we can try CI/CD. Yeah, here itself after storage, I'll try to cover the ingress maybe better. Okay, yeah, you have Helm and you have CI/CD. I think with that you will have the I think monitoring is there, but I don't know how to cover that. You have the logging and you have the monitoring. Okay, so we will see how I can proceed with this. So the reason which I'm trying to stop some topics is some are let's say some are very sorry. Yeah, the reason I'm trying to do is because some are very basic concepts and some are little advanced. I want you to make sure like things are going smooth. And one more thing is this is for the managed cluster, right? So right now for you, I'm explaining just a two VMs. I'm explaining Kubernetes. Okay. But in production, you have this is, no, this is managed cluster. This is a self-managed cluster. We are doing management cluster and self-hosted. Okay. So the problem is now the managed cluster will have AWS to take care of the things. AWS or GCP or something. Okay. But how about the self-hosted one? We have to take care of the maintenance. Okay. And that's where you need your whole networking skills, the next skills to be top. So yeah, we'll see. Yeah, we'll see one by one. After this, I think I'll try to go with this flow and then we'll come to this one. Okay. As I told, it's a very long journey, man. Like maybe it will take up to February or something, but we will see how to do.
Yeah.
Is it okay if I schedule in evening times? The morning is bit difficult, or 3 to 5 or something like that.
Yeah, it's fine for me.
Sure. Anything is fine.
Yeah, I'll ask the availability because some people are having trouble waking up in morning and all. That's okay. Yeah, man. So we should be good, and yeah, we have one more monitoring. This one will come in, but I don't know how to explain monitoring to you because we need to go monitoring concept by default normally, and then come to this. We have one more. Yeah. After this, you have a monitoring subject. After this, you have AWS, and 1 second. You have Ansible. You have Terraform. Ansible would have covered long back, but that's okay. And if you see here, a pathway. Yeah. So we covered Linux basics, networking, Git version, shell scripting, YAML. No, I didn't cover this one. Shell scripting, I didn't go in depth. It's like a self-learning content thing. So we went for the Dockers. We didn't go CI/CD in depth, but we went for GitHub. We went for the load balancer. The cloud basics we didn't touch. Yeah, we will touch when the Kubernetes, Helm, and there are multiple Kubernetes tools on top. So we need to see. And yeah, this is the advanced things, but Yeah, we can see how to go proceed further and all. Yeah, I'm trying to consolidate my website. Like whoever visits, right? They might have a lab guide or this diagrams and all everything to be placed. Now I have 2 weeks time. I can work on the consolidating the web applications and all. So consolidating this web page and all. So yeah, we should be good, right? And I think by the way we are going, it's gonna take long time. I'll see if I can set up 3 hour session or 2 hour session based on that. And one more is like I think this AWS and Terraform. I think I'll do a touch base. We'll see an Ansible. After that, I can close maybe. Or Ansible I'll take out of requirement right now because not many people are using it. Yeah, you might need these things. Prasad asked to set up an interview kind of thing, as in like he asked for an interview preparation. How do you prepare for interview? So let me see. Yeah, guys, sorry for taking long time, but are we good to conclude?
Yes. Yeah.
Yeah, thank you guys.
Yeah.
Thanks for joining.
Yeah. Thank you so
Thank you.
much.
Thank you.
Yeah.
Cheers. Bye.